Hello and welcome to the Getting Started series with Apache Pinot. I'm Matt Landers, Head of Developer Relations at StarTree, and in this video we're going to talk about real-time tables. But before we dive into the specifics of real-time tables in Pinot, let's talk about what real-time actually means. Real-time in Pinot is the end-to-end experience of getting data into the system and then making it queryable out of the system. We want that entire process to be as fast as possible, and that's critical to providing great user experiences to our end users. For instance, we want to allow them to be able to get insights out of the data that's being produced and make actionable decisions on that data. So we can't have a lot of delay there. The smaller the delay is, the faster we can make those decisions about our business. So Pinot is really good at this. In fact, it was created at LinkedIn for this purpose. So if you go on LinkedIn and you view who's viewing my profile or see a lot of the stats and things that they provide to you, all of that's coming out of Pinot. And it's really fast. So if it took seconds to get out of the database, you would never see it because you would just go past that page and not worry about it. But since it's so readily available to you and it's in real time, it's pretty cool to be able to take advantage of that data that's provided out of Pinot. So the way that Pinot works is we can take in events. We're talking about tens of thousands of millions of events per second and load that into the database and have them be immediately queryable. And then that query that runs on top of Pinot needs to be really fast. It needs to be under a second so that our users stick around and gain those insights out of that data. And we can also do things like anomaly detection. And the faster that we can do that, the faster we can stop security threats and things like that. So in this demo, we're going to show you the basics of how to get real-time working in Pinot. Now, if you haven't already watched the previous video to this, you should do that. And there's a link right here that you can click on and go do that. If it's not, you can go to our YouTube channel and search for Getting Started with Pinot and start with the very first video. In that video, we talk about all the different moving parts of Pinot, and then we get our first cluster up and running. So in this video, we assume that you've already got a cluster up and running, and now what we're gonna do is actually ingest real-time events and query them. So what we're gonna do is we're gonna ingest events from the Wikipedia Foundation. They have an event platform where they send all the events about Wikipedia over HTTP, and you can just subscribe to those events and start doing things with them, which is pretty cool that this is available for free to the public. So we're going to do that. So we're going to write a little NodeJS app to read those events from Wikipedia. Then we're going to load those events into Apache Kafka. Now, Apache Kafka, if you haven't used it before, is just an event streaming platform. The reason we're going to use Kafka is that Pinot is already built in with the capability of reading things out of Kafka. So we're going to take Node, we're going to read those events from Wikipedia, throw them into Kafka, and then we're going to create a schema and a real-time table on top of that schema that is hooked up directly to Kafka and loading that data into our database, and then it will be immediately queryable. So this is pretty cool. Now in our example, we're just going to have one node, but just imagine this could be living across thousands of nodes, and that data ingestion is going to work just the same, and those queries are going to be just as fast. It's pretty amazing, actually. So let's dive in, create our first real-time table and query it. All right, here we go. All right, so the first thing that we want to do is connect to the wiki event stream. And the way that we're going to do that is we're going to use NodeJS, write a little script to hook up to the wiki events. And then we're going to pull those down. We're going to write them to files so that we can see them just for debugging. And then we're also going to send them over to Kafka. So let's go ahead and install Node because you're going to need that. So I'm in my Docker container right now that we set up in the previous video. And I'm going to run this command. You can get this command in the YouTube comments or on my repo, which that link is in the YouTube comments as well. All right, and this is adding a repo to apt so that I can go and install Node. All right, so then I'm just going to run apt install Node.js after I get that repo added. That's going to install Node, and just to make sure that it's working, which this only takes a second, I can just type node -v, and I'll see I have Node, and make sure you have npm as well. So if you already have that on your machine, you don't have to worry about it, but I wanted to put those commands in here to make sure that you could follow along if you needed it. We're also going to use Vim, so you can do apt install Vim. I'm just doing this because I want to stay in the terminal and make this really simple rather than copying stuff back and forth to the Docker container. So if you have everything locally, you might not need Vim. You can use whatever text editor you want. All right, so we have Node installed. Now let's go ahead and create a folder for our real-time app that we're going to write. So I'm going to create a directory called real-time. Let's go into that directory. And then I'm going to use Vim to create a wiki events.js file. Now, I'm not going to make you watch me type all this out. It's not that long, but we'll talk about what it does. All right, so here it is. This is the whole file. We basically are going to use the event source package and Kafka.js package in order to connect to the events, because wiki events follows a web standard for event source, and this package just makes it really simple to connect to it. We're going to connect to Kafka, which is we're going to run on port 9092, which is the default port for Kafka. And then if we go down here, you're going to see that whenever we get a message from Wiki, we're going to write it to the file system for now. That's just for debugging purposes. And then we're going to write it to a topic, Wikipedia-events. That's going to be important to remember that. We're going to need that when we create our real-time table. And then we're just basically going to send this straight over as is as we get it from Wiki. And we'll be able to see what that looks like. All right, so I'm going to save this file. And you can get this on the repo as well. All right, now we need to install Kafka to make this work. So to install Kafka, we just need to go and download the package similar to what we did for Pinot. So let me grab that link. All right, so if we go to the previous folder, we're going to download it. Right here, this is where we have Pinot and our real-time folder. We're going to add Kafka to this folder as well. So I'm going to run wget and then get this file. It'll take just a second. All right, now that file has been downloaded, let's go ahead and extract it. So we'll run tar -xvf and then Kafka. All right, so that's going to extract everything into a folder with the same name. Now I'm going to rename this folder just for simplicity's sake as we're moving around. So I'm just going to move it to just Kafka. And I'm going to get rid of that tar file. So, all right. So now we have a nice clean folder here. And now what we want to do is get Kafka running. So let's go into the Kafka folder. And we're going to edit a config file. I'm going to go to the bin folder. This is where I'm going to run it from. But I want to edit the config file for Kafka. And I'll show you why in just a second. So we're going to do PI. I'm going to go back a folder and then go to the server properties. And I'm going to change the zookeeper address right here where it says localhost :2181. That would put all of the zookeeper metadata that Kafka uses directly into the root of my zookeeper, and it would clutter it all up and look bad. So I'm going to add /Kafka at the end of that just to make that not happen, because we have Pinot data in there as well. And then it's hard to tell what's what if you do that. All right, so that's all I'm going to change. I'm going to leave the defaults for everything else. All right, now what we can run is Kafka server start, and then we're going to give it that config file. So we're going to go to the config server properties. I'm going to add ampersand at the end of here so that we can get back to the terminal. All right, so that's going to run and connect up to Zookeeper, get Kafka up and running. And again, Kafka is just a simple event streaming platform. I say simple, it can be pretty complex, but the way that we're going to use it, it's going to be pretty simple. We're just going to send events to Kafka in the form of on topics. So Kafka has this idea that you have a topic and then you send events to that topic. And then we're going to tell Pinot to subscribe to that topic and pull that into the database once we create our schema and our table. All right, well, let's go ahead and go back to our real-time folder. All right, so now we should be able to run this wiki events.js, and it'll start pulling down events from Wikipedia, putting them in files so that we can look at them and see what they look like, and also start pushing them to that topic in Kafka. So let's go ahead and run this. Well, let's make a directory first. I put all these in a events folder. So I create an events folder, and then we should be able to run this with Node. So let's say Node wiki events.js. We need to also install the packages. So npm install event source and Kafka.js. That'll go and download those two packages into your Node module. So now you'll see you have a Node module, a package.json, all the fun stuff that you get with Node. And we should be able to run this. So it's going to open the connection to Wikipedia. It's going to start pulling in all these events, and it's going to be loading them into files into Kafka. All right, so this has been running for a second, so we should have quite a few files because this is a very active event stream. So I'm just going to cancel it here, and then we'll go to the events folder. And you'll see that all of these folders were just created. We can go to the English version and look in here and look at all of these events that happen just in the English version. So we could like cat one of these out. Let's just say, you can see that here's the, oh, it's probably hard to see. Let me clear it. So here's the file. It doesn't look great because it's not formatted. So I have one for us to look at back here. So this is what the JSON looks like that Wiki sends us. We see that we have an ID. We have a unique ID up here that we're going to want to use. This ID I don't think is unique, so we're not going to use that one. But we have this ID here. We have the domain. So this is the English wikipedia.org. We have the type, categorize, the title, the comment, the user, the timestamp. Timestamp's going to be very important. Whenever we're dealing with a real-time table, we've got to have a timestamp. How is it real time if we don't have a time, right? So that is a requirement for a real-time table, is that we do need a timestamp. All right, so this is what the file looks like. I know what this is going to look like, and now we're going to create a schema that can pull in some of this data. We won't pull all of it in. We'll just create some columns to pull some of this data in so that then we can pull it from Kafka and then start reading it. All right, so that's the next thing that we're going to do. Let's do it. All right, now we're in the UI for Pinot, and in here we're going to create our schema and our table. All right, first I want to show you something in Zookeeper. So you remember how we pushed that /Kafka on the Zookeeper command? That's what happened here. So that's why in Zookeeper now we see all our Kafka config. If we hadn't done that, all of these folders and files, I mean, they're not really that, but they're key value pairs, would have been at the root rather than nested. And it gets kind of ugly. It would still work, but when you come in here, it wouldn't look very nice. So we just kind of broke that out. Just wanted to show that. All right, so we have our Pinot cluster up. We don't have any tables, so let's go ahead and create a schema. All right, we're gonna name the schema Wiki Events. All right, actually, we'll just call it Wikipedia. And let's go ahead and add a few things here. We're gonna add an ID, and this will be a dimension. We're only gonna add dimensions for this. This data isn't great to have metrics on, but you get the idea. If you could add a metric as well if you had data that required it. And then let's add another one. We also want to add our timestamp. We have to have this. So this is our date time field. And this is already right. So it's a epoch and milliseconds. What else can we add? We can grab the user. That's also a dimension. And we're just going to add a few fields here. I'm actually going to replace this with a whole thing that I've already created, but I just want to show. You would come through here, create dimensions for every field that you wanted to pull out of that JSON, and then we'll write the real-time table, and we'll be able to transform and move some of those nested elements into the columns as well. So for instance, in our nested elements, we had that ID. So I'll show you how to map that with a transform function here in just a second as well. All right, so if we save this, we end up with our schema. And then the next thing that we want to do is we want to create that real-time table. But I have this schema config on the Getting Started with Apache Pinot repo on my GitHub. So definitely you can just pull that down and add it from the command line. And the real-time table config is there as well if you don't want to go through and create all this, but I wanted to show it and how you would do it. All right, so now let's create our real-time table. To create a real-time table, it's pretty simple. We're just going to click the Add Real-Time Table up here. And if we name our table the same as our schema, it'll automatically pull in our timestamp column if there's only one. If not, you can click this drop down and choose the timestamp column that you want. We only have one, and it's called timestamp. We need that for a real-time table because real-time tables are based on time, and we segment that data based on lengths of time. So we have to have a time column on a real-time table. All right, so we have that. Now let's go down and look at our stream config. So if we scroll down, this is different than our offline tables, which we saw in the previous videos. But this is where we configure how we want to get that streaming data into the table. And we're going to use Kafka. So it's a streaming type of Kafka. And this is already set up for Kafka immediately in the UI because that's what most people are using to stream data in here. But you can use different plugins to pull in data from different places as well. We need to put in our broker list. So here you're going to want to put localhost 9092. That was the port that we ran this on when we ran Kafka. So we just got to get that going. And then remember in our JavaScript file, we called our topic name Wikipedia Events. All right, and then what's going to happen is it's going to use this decoder class here, which uses the Kafka JSON message decoder, which is the default. And that will parse the topic messages from Kafka. And if they're in the root, then it'll just automatically map them to the columns. So if the root property in the JSON matches a column name, it's going to try to map that over automatically, and we don't have to do anything. Now, there are a few columns that we chose that are under the meta property. And under there was more JSON. So we're going to have to do some transform configs to get to those. The other option was that we could have flattened that when we put it into Kafka, but you might not have that option. You might have other things that are reading from the stream, which you probably do. So we want to be able to take the JSON as it exists and then map that to the right columns. So the first thing we're going to do is we're going to go up to this transform functions, and we're going to add a new transform function on the meta JSON field. Now, when we created this schema, we didn't put all of these fields in here. I went ahead and added them all. The meta JSON field is just a string field, but we're going to put JSON in it. So we're going to say JSON format in meta. So in our JSON that we get from Wikipedia, there's a property called meta, and that's what I'm referencing here. And that's just a nested list of more properties like the ID and a couple other things like stream, domain, and topic that we're going to pull out of there. So we need to add this JSON to a column in our table in order to use some of these other transform functions. So one of them that we're going to do is the ID. So we're going to say JSON Path this time. We're going to reference the meta JSON field as to where our JSON exists, which we just created here. So we have to create that in order to reference that here. And then in quotes, single quotes, we're going to put $.id. So this uses the JSON Path syntax, which is a standard. So if you've never seen it, you can look it up, just JSON Path. But usually $ is the root of whatever the document is, and then dot property indexers, just like you would use in most languages or whenever you're referencing JSON in JavaScript. So we have a couple of other columns here that we're going to add. I'll just do another one real quick. So we'll do the stream, that was also in the meta. So same thing, just meta JSON is the field, and then $.stream. It's just pulling data out of that document. All right, so once we define all of our transforms and everything, we can come down here and just save it, and then that's going to go ahead and create that real-time table. Now this real-time table should go out to Kafka and start listening to the stream, and as we pump events to it, it should start to populate. So let's go see if we can get some data in there now. All right, so let's see what happens if we just go ahead and query this table. So we'll go to our query console, we'll click Wikipedia, and we'll see that we have data in here already. Now our event streaming isn't running right now, but we have data in here. In fact, we have 1,069 docs that we went through, and we can see all the data coming out of here. And the reason for that is that Kafka isn't ephemeral. Kafka keeps those topics and messages around. So whenever we created the table, Pinot hooked up to that topic and pulled in whatever data was there. Now, if we start streaming data, we'll see more data fall in here as well. So let's go ahead and start our stream. Go back over here. Let's go to our JavaScript file, and we'll just run node wiki events. Now we're open up. we're talking to the wiki events, we're pulling those events in, we're writing JSON files, which we should probably comment out because that's going to make a huge folder. So go ahead and do that if you want. I'm just going to leave it for now. But now let's go back over to our browser and see what's happening. So if we run this query again, look at this. Now we're at 1,822 docs, 1,939. So these things are being loaded in real time as they're actually happening on Wikipedia. That's pretty cool. So now we can start to query this data in a more meaningful way. So let's see, let's pull out the user. Let's see who is making all of these edits. So we can do something like count user, and we'll pull back the user as well. And then we'll do group by user, order by count user, descending. All right, we'll run that. We come down here and we see that Yaya, it has made 186 edits in a matter of seconds. A lot of the things that are editing the Wikipedia stuff are bots. You'll see some of them are actually called bots. Like, I don't know what exactly they all do. Maybe you want to look into that. But most of them are bots, and then some of them will come through as actual people making changes. But yes, they have bots running through and cleaning things up all the time. So that's where a lot of these messages are coming through. But you can play with this data and see that now we're at 3,403 docs. So you can imagine that over the course of a day or a few days, a month, this data could get really, really huge. And we would want to spread our data across multiple servers and scale that out. But we would want to just make sure that we maintain this really fast query response time that we have here. I mean, this is 24 milliseconds right now. Obviously, it's not a ton of data, but it isn't insignificant at this point. And it's growing as we sit here. We're at 5,000 now. All right, so this is pretty cool. So now you kind of get the idea of how our real-time table works. It goes out, it connects to a streaming source, which you can create plugins for any streaming source. There's some for Kafka and a few of the cloud providers, different messaging systems that you can connect to as well. If you need a custom one for whatever you use, then you can create one as well in Java as a plugin. So it connects to that streaming source, it pulls it in, decodes the message, and then maps that to columns in your database. And this happens in real time. As soon as those messages come in, they're immediately queryable. So this gives you the basic overview of how real-time tables work. If you have any questions, ask in the comments. Definitely check out the repo. And if you're interested in Apache Pinot, please join our Slack channel. You can find that at pinot.apache.org and ask questions in there, get to know the community and introduce yourself. We're really excited at how fast the community is growing and how many people are loving and adopting Pinot. So please come join us. And until then, go build you some real-time tables, write some apps that run off of that data that you have in your organization, and happy coding.